This unit is going to be very similar to what we did with equations, except we're going to be dealing with things called inequalities and learning what they represent. So the first thing we want to think of are some words that mean unequal or not equal. So such words could be more than, we could have less than, we could say greater than, and so on. So these words all mean not equal because they don't say is or is the same as. They don't use those words. So we're going to talk about how to work with problems like that. What inequalities do is, before when we did an equation, let's say x plus 2 equals 6. The only possible answer that will work for x is 4, because when I put 4 in here, 4 plus 2 does equal 6. So there's exactly one answer. So we talked about problems that had exactly one answer, no answers, or infinite answers. What if I change the problem to this? X plus 2 is more than 6. So I want you to find numbers that I can plug in for x so that my answer is more than 6. One example could be 7. 5 will work. 6, 8, 9, 10, etc. And we could really go on forever. But we don't really want to write that there's many solutions or infinite solutions, because while we can keep coming up with new answers, it's not like I can plug anything I want in for x. Like if I plug 1 in, 1 plus 2 is not more than 6. So I can't just write any solution. So the way we're going to show this basically means any number that's more than 4. Anything more than 4, when I add 2, it'll be more than 6. So we're going to write our answer using an inequality symbol. We always want to write our symbol with the letter on the left. And there's a reason for it, but for right now, and just kind of get that in our heads, we always want our letter to be on the left. So there are 4 symbols, and these might look familiar from back in middle school. This symbol right here, we read it from left to right, so it's the less than symbol. The symbol is also less than or equal to. And that underline means can also equal. This symbol means greater than, where this one is greater than or equal to. So we're going to have to remember those symbols, and a really easy way to remember at least one of them is think of the less than symbol as an L. It looks almost like an L. So I like to write this at the top of all my papers. So then obviously if your little symbol is going the other way, it's going to be greater, it's going to be opposite. Now there's a little trick I want to teach you to get the letter on the left, and I call it the swap, flip trick. Swap, flip trick. If you look over here, I don't like this because my variable, my letter, is on the right side of the symbol. I want it to be on the left side. So what we're going to do is we're going to swap 7 and y. So they're going to swap places, and we must flip sign. So before, my problem looked like this. So I will swap places and flip my sign. And that's my answer. And it reads numbers less than or equal to 7. Now let's try that with the following examples. So swap places, flip the sign. Swap places and flip the sign. So we're actually going to use that trick to help us graph inequalities on a number line. So again, the letter must be on the left. And you're going to be using one of these 4 symbols. So if you see a symbol that says greater or equal to, you use a solid dot, and your arrow goes basically the same way as your caret points. Your caret is pointing that way, so your arrow is going to go that way. And so in this one, this little underline here still means a solid dot. The solid dot means it's included. And your arrow is going to go left this time. For this one, there's no underline, so it's going to be an open dot. It's going to go to the right. This one also has no underline, so it's an open dot and goes to the left. So we're going to practice graphing a couple. First one, r is less than 5. So we're going to put an open dot. We're going to go left. And you don't have to draw your arrow crazy long. You can just put it somewhere on the number line. That's fine. Now what this means is I'm asking you for numbers less than 5. 5 is not included as an answer because 5 is not less than itself. If it said less than or equal, then 5 would be included. Now the next one says x or numbers more than or equal to 3. So we're going to put a solid dot at 3, and we're going to point in the direction of our arrow. Now 3 is included as an answer because it can equal 3. So I'm looking for numbers that are either the same or more than 3. Any of those numbers would work. Numbers more than -2. Now it does not say equal, so there's no solid dot and it should go to the right. And the last one says numbers more than or equal to -4. So let's show that. Equal to -4 means a solid dot. And then our arrow is going to go to the right towards numbers more than -4. So in examples 10 through 12, if you notice, the letter is not on the left side. So do not graph it yet. You have to do the swap flip trick. So let's do that very quickly. We're going to swap places and we're going to flip our sign. We're going to swap places and we're going to flip our sign. Just like that. And then go ahead and circle your answer so you don't use the wrong inequality to graph. And we're going to graph these 3. And you want to check your answers with mine. Should have solid dots in the last 2 because of that little underline. That means can also equal. but there is no solid dot in here because -5 does not work if I plug it in here. All right. So let's talk about what the closed dot means exactly. It means that the point it's on is also a solution. And we call that inclusive. So let's talk about what that means. Solutions are numbers that work, numbers that satisfy the problem. So if you think about going to Hershey Park, you see the Hershey Bar guy standing by a ride and he says, you must be at least this tall or at least 4 feet tall to ride. Well then if you are 4 feet tall, you made the cut, you can go on the ride. So you can ride if you're 4 feet tall. So that 4 would have a closed dot on it, and that means it counts as a solution. It works. Whereas the open dot means the opposite. It means the point is not a solution. And we'd say that's non-inclusive. So let's say you're having a party. Mom says, you can have some company over, but you have to have less than 5 people. So that means you can have 0, 1, 2, 3, or 4 people. You may not have 5 people, because Mom said less than 5. She didn't say not more than 5, she said less than. So 5 does not count. So 5 is not included. So we're going to finish up here by basically looking at the graphs. We're going to write an inequality to match the graphs. And we're going to work a little backwards here. So you always start with a letter. You can pick any letter you want. I'm going to use P. Now my arrow is pointing to the left, so my caret should point to the left. And it's a solid dot, so that means I need to underline. And then the dot it's on is 5. That's it. This one is everything's the same except there's no solid dot here, so there's no underline. This one has a solid dot and points to the right. So I'm going to point to the right and underline. This one has an open dot, so no underline, but it points to the right, and the number is still 5. So 5 is the endpoint on all of these solution sets or all of these inequalities, but you have to change the direction of your arrow based on which way it's going. And again, it only works that way if your letter is on the left. If I switch places with these, then it's going to make it a lot harder to graph. So put that letter on the left side always.